Hello everybody. Good morning or good afternoon, wherever you happen to be in the world. My name is Jason Hodgert. I'm with PCI Geomatics, and I will be hosting you today during our latest webinar, Urban and City Modeling using Geomatica, CityEngine, and 3D FeatureXtract. What we're going to be showing you today is a really interesting set of demonstrations that we've put together. And basically, it's about using your high-resolution stereo imagery. If you have it, we have a couple of really easy ways that you can model 3D features using an automatically generated digital surface model using Geomatica, some building footprints, and a couple of different packages of software depending on the level of detail that you require. What we're going to show you today through the demonstrations is how you can create these DSMs, and then using a product from ESRI, ESRI CityEngine, can build these 3D models with very little manual input at all. And then for a higher level of detail, for perhaps iconic buildings or specific items that you really want an extra level of detail, there is a product that we provide here at PCI Geomatics called 3D FeatureXtract, or 3DFE for short, that will allow you to do that very easily. And all of this can be done without any special 3D equipment, no special hardware, hand wheels, 3D glasses, nothing like that. So it's really innovative, it's really simple, and we're really excited to show it to you today. I'll briefly talk about just some of the logistics about how a GoToWebinar presentation works if you're not familiar. Right now, all of your lines are muted during the course of the presentation, but we will have an opportunity to unmute you if you have a question. We will be having a question and answer session at the end of the presentation, at which point you can feel free to raise your hand using the little hand icon on your interface. And if you have a microphone, you can feel free to ask us a question verbally over that. Or more traditionally, you'll see that you have a questions panel on your interface as well, and you can type a question into that panel at any time, and we'll save the questions for the end. So if you have a question, type it in. We will save it to the end for the question and answer session. And lastly, we will be recording this session. I'm recording myself right now. So so if you like what you see and you want to watch it later at your leisure or share it amongst your friends and colleagues, you will be able to do that in the coming day or so after we put the recording together. Presenting today, we have Mr. Jeff Taylor from ESRI. He's a 3D solution engineer, and he is put together an excellent demonstration showing how to use ESRI's CityEngine software to automatically develop these 3D models that we're talking about. And then also we have Kevin Jones from PCI Geomatics. He's up here in Ottawa, Canada, with me, and he will be demonstrating a little bit about Geomatica, how we produce these the DSMs that start making the 3D models, and then this tool that I described earlier about how getting an extra level of detail through 3D FeatureXtract. Kevin will be doing a live demonstration of that to show how we can do those kinds of things. So a couple of things that I'm going to be doing today is we like to ask a few polls throughout the session, and these polls really help us get a better understanding of who we're speaking to and whether the webinars that we're delivering speak to you, whether they are delivering information that is useful to you, and it helps us actually do better work in the future with our software and our delivery of these tools. So this first poll is what is your level of involvement in 3D modeling? Perhaps you haven't done any, but you're interested, being it is the next thing, the next big thing in GIS and image analysis. Perhaps you've done some, but you're not really happy with the tools that you're using. Maybe they're a little too cumbersome or a little too hard to use. Or maybe you just purchased the 3D building models from somebody else making them because it's quicker and easier to do that way. Or you're just, what is this 3D all about? and you're interested to learn more. Excellent. Most people have had a chance to vote there. Thank you all for taking part in that first poll. Just a quick update of the situation there. A pretty even split. There are a number of you that are have not modeled yet, and some of you have been starting to do some modeling and are looking for an alternative to your current solution, which is a great opportunity for me to pass it right now to Kevin Jones, and he'll set up the use case and the business case for the tools that we're about to show you with Geomatica, CityEngine, and 3D FeatureXtract. Go ahead, Kevin. I'll pass it to you.
Thanks very much, Jason, and welcome everyone to our webinar. It's a real pleasure and an honor to be able to present to you today on this very interesting topic, 3D modeling using stereo imagery. We do have other topics that are related to elevation models that I want to highlight to you. I'll just show you quickly a webinar that we presented last week on using elevation models for mining and construction applications. After that, we're going to talk a little bit about two different approaches to look to derive building information. So the first approach we're going to look at is a combination of Geomatica and stereo imagery to derive a digital surface model, or a DSM. Once we add the DSM to the building outlines and we bring those into CityEngine, we can automatically generate 3D buildings using procedural rules, and Jeff Taylor, who's on the line, is going to be showing that. So I'll show you a little bit about how easy it is to generate DSMs, and Jeff is going to show you how easy it is to generate the buildings from those DSMs with the building outlines. Following that, I'll give a few slides, I'll give a live demonstration. Then we're going to look at more detailed building. So how do we create really a photogrammetrically accurate building with all the detailing that we need, or otherwise said, how do we model iconic buildings? And so we're going to be using a software tool that is available through PCI Geomatics. It's called 3D FE, which is short for 3D FeatureXtract, and the same stereo imagery over Raleigh, North Carolina. And then we'll show how, again, Jeff will come on and he'll show how he can bring those models into CityEngine to improve the level of detail that is available through the modeling approach. And then the last part of the presentation is going to be on publishing the contents and sharing them out through ArcGIS Online. Jeff is going to be showing that and some of the analytic possibilities that are available within the CityEngine online web interface. So just a really quick note here, if you are interested in the topic of digital elevation models and digital surface models, we presented this interesting webinar last week on the use of multi-temporal stereo data to derive elevation information, in this case to calculate volumetric information on the different stockpiles of aggregate material on this particular construction site. So if you want to find out more about that, please go ahead and search up this recorded webinar on our website. So how do we leverage existing stereo imagery? This webinar series is all about doing more with imagery than just using it as a backdrop. There's a lot of content that is in imagery, and all we need to do is basically understand what content we can extract, how we can use it, and leverage software tools that are easy to use to derive that content. So when we talk about stereo imagery, primarily within the Geomatica software suite, we are supporting two different types. One is aerial digital frame cameras, or analog cameras even can be supported. Those types of surveys are typically flown with 80% or more forward overlap and then 60% side overlap, which gives us multiple views of the different features. And from that we can use the parallax information from the different viewing geometries to match the features and extract the elevation point at a particular pixel spacing or a ground sample distance in our DeEM. The other approach that we can be using is stereo imagery. So here we have the two examples. So on the top we have high resolution digital frame cameras. So we have UltraCam and DMC cameras that are available. These are typically flown by data providers like Sanborn and those types of companies. And they will deliver to you, if you wish to have them, they will deliver raw TIFF images to you, as well as aero-triangulated math model for each image, which includes the interior and exterior orientation information, which you can then use to bring into the Geomatica software. Satellite imagery works very similarly. In the case of satellite imagery, we have these RPC, or what are known as raster polynomial coefficients, that represent the position of the sensor relative to the ground, so that we can leverage the basically reconcile a camera model and leverage the parallax information contained in the stereo satellite imagery. This is just a quick look here at how the interface looks within the PCI software. This is Geomatica, and within Geomatica there's a module called OrthoEngine. On the left we see an air photo project where we see a lot of forward overlap and side lap, and on the right we see a satellite project. Workflow is very, very similar. There's a few little differences, but it's quite an easy workflow to learn and implement, and even to automate. We have automation tools within our software. We also have automation tools for We also have automation tools with Python. So if you are a developer and you're comfortable leveraging Python, you can certainly call the functions within our software as well as functions from other software and build a customized workflow that suits your particular purpose. This is just to give you a sense of the quality or the resolution of digital surface models that can be generated. This is a dense urban area where we have some vegetation and some commercial buildings and some residential dwellings. So this is 15-centimeter imagery. It's not zoomed in at one-to-one resolution, but it's a large portion of the data set here. And if I switch over to the next slide, which is the equivalent area, but this time what we're showing is the digital surface model, we can see the buildings. This is not LiDAR quality, but it's definitely something that is high quality and does contain very good elevation information, and it can be leveraged. This is, if you are in possession of existing stereo imagery, you can quite simply acquire our software and run your stereo imagery through it to derive this kind of information very easily. If we go to the next slide, just some 3D representations of the imagery draped on top of the DSM to give you a sense of the resolution that could be accomplished. Next slide. Here we see some residential areas and a sort of a natural cliff here. So these are not building models. These are just the images draped on top of the buildings, and definitely not something that is an acceptable quality. But what we can do is we can overlay the building footprint information on top of the DSM, remove the digital surface model, and arrive at a DTM, or digital terrain model. And what we're left with is a normalized DSM, which is essentially the surface elevation without any underlying terrain elevation, and we can estimate building height. So here we have average elevation of 224 meters above mean sea level, and then the ground is about 217, so we can calculate that the estimated building height is 7.2 meters roughly. If we just go to the next slide. Sorry, yep. Okay, so I'm going to pass over to, actually, before I do that, just before I pass over to you, Jeff, I just want to quickly show the OrthoEngine interface so that people get a sense of how easy it is to work with our software to derive so the starting point for this demonstration is really the stereo data. And so if I open up Geomatica here, I will launch OrthoEngine, which is the tool that I was referring to. And I can go ahead and open the project, which has already been set up. So essentially the project is all set up. We have a number of overlapping images here that are over the study area, or over this. The location is actually Raleigh, North Carolina. And we can quite simply pull down the DEM from stereo menu here. The first step would be to create epipolar images to match the stereo pairs to each other, and from that we can extract a DEM automatically. So I'll just load up the DSM, which is what Jeff is going to be working with, or where he's going to be starting from. So if I just head over to that folder. So this is roughly a 2-foot resolution DSM, which is about what we're able to extract here from this imagery, and you can get a sense of the features in the downtown Raleigh area. Obviously, we have some results that are really quite good over different types of buildings. You know, the results are maybe a little bit less optimal where we have higher buildings, just because the matching algorithm doesn't do quite as good a job. But we do have good enough information here that we can pass this on to CityEngine, and using the actual outline of the different buildings, the elevation information can be extracted and automatic models can be created. So with that, I'm going to pass it back to you, Jason.
Oh, thank you, Kevin. There we go. Having some issue with the mute button today. Yeah, I'm going to pass it on to Jeff now. I'm just going to take control back to get the slides back on the screen. And at this point, I'm going to introduce everybody officially to Jeff Taylor, who's going to walk us through the process of making these models in ESRI's CityEngine. Go ahead, Jeff.
All right, thanks, Jason and Kevin. So a lot of great things taking place already. So we've been able to extract out some terrain models from your land records imagery or other imagery you may have acquired or flown. So the next steps that we want to go through involve a series of software packages. First of all, a lot of you already know about ArcGIS Desktop. It's one of ESRI's flagship products, basically ESRI's main product. But a lot of you may not have heard of ESRI CityEngine before. It's a really awesome tool for transforming your 2D GIS data into a smart 3D city model. And we can muted this digital surface model that Kevin just demoed a second ago inside of ArcGIS to add attributes to your building footprints, and then apply rules in CityEngine that transform your data into 3D. And I'll show you more of what that is here in a second. It's kind of hard to grasp at first. So I urge you to, if you haven't done so yet before or have never played with CityEngine, go to esri.com/CityEngine and download a free 30-day trial of CityEngine Advanced. Next slide. So also feel free to go to arcgis.com and download a free trial of ArcGIS for desktop, which will allow you to process your data and optimize it for CityEngine. So in transforming a city into 3D from existing 2D data, what we've done is we've created a data model that will help you out with this process. It's called the 3D City Information Model. You can easily transfer your existing city data into this, or you can leverage existing data without going into this model and still be successful, one of the two. We also have provided tools in this 3D City Information Model which will allow anyone to be successful with transforming their 2D GIS data into 3D and leveraging those rasters you saw earlier. So we can even take in CityGML and other data formats directly into this 3D City Information Model. Next slide. So where can I go to get this 3D city information model and learn more? Well, if you go to github.com, there's an ESRI GitHub page, and you can just search for 3D city on this location, and it'll take you directly to the repository for where these this information is for the 3D city information model. Next slide. And with this information model, you're going to get a lot of tools. So a tool that will allow you to calculate your building height, to automatically create these data models. It'll show you how to load your data into this data model very quickly, and this will really speed up the process. And we have CityEngine rules that automatically link to this data schema that will help to quickly transform your data into 3D. So with that being said, let's jump on into a live demo, or a recorded demo. All right, show my screen. Make sure we can see it. Okay, so when you first open up CityEngine, you have a lot of options to bring in data and information. So we're going to select the digital terrain model that we created in Geomatica. And then we're going to select an ortho, or the ortho mosaic that was also created in Geomatica. And what's going to happen in CityEngine is it's automatically going to create the terrain, load it in, and place the ortho directly on top of the terrain in the correct projection and location based on your information. You can also take in your data that's been transformed to 3D using those 3D city information model geoprocessing tools directly in on top of this data set. So I can select all these building footprints and tree points or other city data such as streets and align them directly to the terrain by translating them to the minimum or another value and selecting the terrain and selecting finish. And it's going to place all the building footprints and tree points directly on top of that 3D topo. So from there, I can assign a rule file to the building footprints, and rules are procedural rules. They're basically coded language that leverages your GIS data attributes and transforms your data into that third dimension. So we could have the slope information of a roof, the total height, the eave height, pulled from the imagery, and it would automatically create a geotypical model for how those buildings really look based off of the best data that you have. So we'll give it a couple of seconds and it'll generate. And you see all the buildings just generated in 3D. Well, some other things that we can do is we can either extract tree points from LiDAR, you can use existing tree data, you can derive shapes where they need to exist out of your imagery with other processes, using different GIS processes, and you can scatter points across those shapes. And we can start to generate trees where they really are in the environment, or geotypically as to where they are, and derive the heights of this vegetation from these digital surface models from LiDAR, or that you can create with PCI's tools. And we're going to fly around just for a second to give you an idea of the quality of these models that can be generated. Now, then again, some of these taller buildings are not going to look as accurate as they look in reality because they may have a more steep slope, they may have different angles on the roofs, and they may not just be as boxy as the footprint. But this just takes into consideration your building footprint and uses your LiDAR heights and just transforms that in an extrusion. So let's see how these procedural rules work and operate. So I'm going to select a building, and I'm going to open up the inspector. What I can easily do is move this slider, and you see with just some simple changes, the heights of the buildings change. So any attribute can adapt, and this is why CityEngine is also great for urban design and planning applications as well. And I recommend checking out some of the other previous webinars that we've done on CityEngine TV on the YouTube channel that we have available to learn more about those as well. But we can also select other existing features such as tree points and apply rules to them as we did earlier. And then we can change all these characteristics of how the tree should look. So what's the genus species? We can change the height, the representation of these models. Is it a lightweight plane type model? Is it a high resolution 3D model using our Lumen RT plant library? Or is it an analytical volume which allows you to do heat island effect studies in 3D analysis or other kinds of studies leveraging 3D volumes? So once we have these models created, we can export a Webscene just by going to a File Export and CityEngine Webscene as you just saw. And we can choose a name, select Next, and this allows us to share this 3D model on the web. So when I select Finish here, what you're going to see is this model generate in the background from everything that we've brought in and applied rules to. And this is the final output. And these can be shared on ArcGIS Online, allowing anyone to share, communicate, and collaborate in the web. We even have 3D commenting capabilities in these things. We have solar shadow analysis, as I can show you here in a little while, and the ability to select any feature, and it has its information. It retains its GIS data attributes. And that's where it's very intelligent compared to a lot of other systems out there. And you can even select smaller areas, focus on a specific part of your 3D model. Maybe it's a planning, economic development project, and you only want the general public or people internally to see specific elements to make sure that you gain their approval for certain requirements. So what I've quickly shown you is how to create a procedural geotypical model of the built environment. But what if you want to go a step further and get ultra realism in this model? And I'll kind of show you what that process is here in a second. But before we do that, I'd like to go back to Kevin and have him talk about 3D FeatureXtract.
Unmuted.
Perfect. Thanks, Jeff, very much for that. Before we get to that, I'm just going to go back and share my screen one more time here. And we're going to do another poll just to see how everybody is everybody's hanging in there. Now, as Kevin mentioned during the initial part, one of the things that's a requirement to do building these models and the surface model and the 3D model is having proper 3D stereo imagery of your area of interest. So basically, we're looking to know which basically, do you have the proper stereo imagery? I'm just going to give it a moment to get people their chance to enter their answer. Perfect. Thanks, everybody. And just share the results real quick. About a third, more or less. About a third of you have only ortho-rectified images. Little more than a third have the proper stereo overlapping aerial or satellite imagery, and actually a third don't have any imagery at all. So if perhaps you're looking to build these models, you can contact us or look for a way. We have tutorials on our website on ways that you can find data and set you up with data providers to get what you need there. And at this point now, Kevin is going to be talking about and doing a demonstration on reaching a next level of detail with a product that we distribute here at PCI called 3D FeatureXtract. Back to you, Kevin.
Great, thanks, Jason. So let's now go into the next level, so looking at how we can leverage once again that stereo imagery, whether it's satellite or aerial, to derive much more detail on those buildings, and also to properly represent those buildings in terms of all of the features that are contained on them. So the traditional approach is typically using lenticular screens or polarized screens or polarized glasses and some special hardware. This tool that we're about to show you here, it doesn't use any of that, and it doesn't require any kind of special training of 3D operators or anything like that. So if I can just jump ahead to the next one. So really it's a much easier to use interface. Here you see what the interface kind of looks like. I'm going to load it here in a second. We have stereo overlapping images displayed in the left and the right screen. We can draw on the left or the right. We can measure different features. Basically anything that's casting a shadow that we know is above the ground can be modeled. There's a lot of drawing tools that make it easy to pre-configure different features. Here we see a swimming pool that has a circular shape, so rather than having to draw all vertices along the edge of that, we could just draw 3 vertices and then it calculates the exact perimeter of that feature. There's other types of complex roof types that can be pre-generated. On the left we see a dome feature that is generated. And the other thing that we can do, obviously, is we can extrude down the geometry from the tops of the buildings to the ground, to the digital elevation model, so that we have a proper 3D building that's extruded all the way down to the ground. So it's very easy to do this. I'm going to be giving a live demonstration. The concept is simple. We draw the feature on the left or the right viewer. It doesn't matter which one. Once we drop that feature, it appears on the right screen. And what we do is we leverage the parallax. So the reason the rooftop doesn't line up is because the building moved in terms of its location with respect to the camera view, because the camera's moved forward or backwards. And so when we move that along the epipolar axis, we can now reconcile the proper slope of that roof and also the height of that roof in the 3D FeatureXtract software. So really the big benefit is you can get very accurate results. So like I said, the input imagery is really going to drive the level of detail that you can achieve in terms of pulling out different objects. On the left here we see the wireframe geometry that's been extracted out, which we actually provided to Jeff, and he'll show you that in a minute, how he can bring in the more detailed models back into CityEngine and share them out. And on the right we see the textures that have been automatically extracted from the images themselves. Obviously, the more images you have, the more views you have on the different facades of the buildings, the better it's going to be for generating textures automatically. If we want to get better textures, we can use other texturing tools as well, and I'll talk about that in a second. All right, so I'm going to grab the control once again and give you a quick tour of 3D FeatureXtract. So what I've done is I've launched the software here. I'm going to load a project which I previously set up. So here's all the same imagery that was used for the extraction of the digital surface model. And there's a camera model that's been set up for each one of these. I can optionally put in a more precise DEM so that when I'm extruding down to the ground, it's extruding perfectly to that local elevation. There is a built-in DEM in the software that does an approximation of the location. So if I switch over to the Home tab, I've got a nice gallery here of all of my images. So I'm going to load one of the images in the left viewer, and I'm also going to load the next image in the right viewer. Then what I can do is I can lock those cameras so that as I'm panning and zooming around, what I'm getting is the same thing on both sides of the screen. All right, so that's essentially how it works. I'm going to orient myself north up. I just like to know where I'm going when I'm doing this, so I'm going to orient the images north up. Then I can go to my Feature Extraction tab. This is where I do all the drawing, and I'm going to turn off that layer. This is the layer that we passed over to Jeff, by the way, that is available as part of the download. If you want to, all of this imagery that I'm showing here we make available as part of the download, so you can download the software and work with this imagery and get familiar with the interface. So what I'll do is I'll turn on this one building that I want to model here. I'm just going to delete it. I did this earlier today. I'm going to zoom into it. This is what we consider an iconic building. This is the state capitol building for North Carolina. And as you can see, we have a few complex structures here that we can model quite easily. So typically what we do is we work from the lowest feature up, and I'm speaking now of the roof. So I'm going to start with this portion of the roof. I'm going to draw along the longest line segment, or along the longest segment of that roof. Oops. And I can choose different options. There I was in polygon mode, so I can draw an irregular polygon. But this is a square feature, or a rectangular feature. So I can just draw out two vertices, and then once I've locked in my two vertices, it gives me a perfect box. Right click, whoops, I'll just close that out. Sorry about that. So I'll just click a third time there. All right, so you can see here that I can move this feature in along different axes. What I want to do is move it along the epipolar axis so that I can reconcile the exact location of that roof in 3D space. So that's done. So this roof is basically, that portion is done. I can already preset, I can use preset roof types to build the geometry up of that particular roof. So here what I've done is I've selected a gable roof, and you can see now that I'm lining up the center line with that roof. And once I've done that, that's done. That roof is complete. And as I'm drawing, I can actually pull up a 3D viewer to get a sense of where I am. So I'm just going to keep this over here, and every now and then I'll bring it into the view to give you a sense of how that could be used. All right, so the next part of my roof is going to be the opposite side of the one that's going north-south, this part of the roof. So I'm just going to draw a rough shape here, rectangular shape. So I'll close that out, move it in epipolar space. That's done. Then what I'm going to do is I'm going to draw this part of the roof, which is the next level up from that other roof that other roof portion that I was drawing. So I'll draw this one. All right, that's done. I'll drag that into place. So again, there's a lot of nice tools for making quick work of drawing these different features. So I'll select these two structures, and what I can do is I can use the loft feature to connect these vertices and create the planes automatically. So I'll just click the loft, and you can see what that did is it connected my two polygons together, and it's created the right geometry. So let's just take a look here, see how my building's coming along. So you can see that I can get a sense of whether these roofs are properly being modeled. So everything looks good so far. So I'll just move that over for a sec. All right, and the next thing I'll do is I'll create this really complex dome structure here. This will obviously be something that would be difficult to draw. So what I'll do is I'll just zoom in here so I can get a better view of it. And the dome is actually made up of multiple layers. So what I'll do is I'll start by drawing an irregular polygon along the lowest part of the dome, which is this outer octagon shape. So I'll just draw that quickly. Drop that in, move it here, and it looks like there's another inside shape here that I can pick up and draw. So I'm going to draw that. Just being pretty rough here. I can obviously spend more time on this, but I'm doing a rough job here. And then the next level up, it looks like, is this dome. So I'm going to switch to the ellipse mode. I can draw a circle, and once again I can pick 3 points on that circle. So I'll go 1, 2, 3, done, move that in place. Now what I'll do is I'll extrude or create the geometry for that. So this is a dome structure, and I can adjust the height here, try to line it up in the middle as best as I can. Click OK. Now let's take a look and see how that's coming along. So that's looking all right for now. Here's our structure. Okay, so now we can start extruding these to build up the geometry all the way to the ground. So what I'll do is I'll simply select the bottom part of this polygon. I'll extrude it down to the ground. So there we go. We can move the bottom part of the polygon to where the building ends. So I can actually move it along the z-axis here. I'll click this polygon next, the bottom part of this polygon. I'll extrude that down to the ground, and I can click on the again the bottom polygon and move it along the z-axis. And the next thing I'll do is I will click on this bottom feature, which is this guy, And I'll just bring this over here because it's kind of neat. You can see it come down. So in this case, what I'll do is I'll do extrusion, planar extrusion, and you can see what it did is it extruded down to the next level from along the model. And then I'll extrude this part of the polygon as well. Oh, I probably reversed the order there, but essentially this gives you a sense of how the model is coming along. And once we're done here, we can save this model out. So I'm not going to do any other buildings. I'm just going to work on, just wanted to show you this particular iconic building for now. What we can do is we can go to the backstage. We can save this out and export it to a variety of different formats. And some of these formats are open standards. So Collada is an open standard for exchanging 3D models. And also the texture information can be included with it. So we can select the images and export that out to a particular folder. So it gives you a DAE file, and from that basically we can bring that then back into CityEngine and do some more analysis with these more detailed buildings. That is probably it for me. I think at this point I want to pass it back to Jeff, who's going to show you how you can take these more detailed building models back into CityEngine and do some more cool stuff with them.
Okay, thanks, Kevin. So let me show my screen real quick. Okay, so now that we have iconic buildings where we didn't have them before and needed them, just because the other ones look like just extruded boxes, we couldn't get enough information on the building form, we can easily import those models in multiple different formats, KMZ, Object, Collada. In this case, we want to even just drag and drop it directly into the viewport. So I'm going to open up the KMZ file, and I'm going to select the Raleigh.kmz project folder and drag it right in. And it's going to place these models directly in their correct location in the viewport. What we can then do, that's really great about CityEngine, is we can select all of these buildings, and we can use CityEngine to even clean up some shapes after the fact. So some post-processing and editing on these models, updating of textured areas where something may have happened in 3DFE. Not that I'm saying there's any issues, but just to give you more flexibility. So we can remove extra vertices here, further optimizing these geometries. And you select this one as well, clean it up, and there we go. You can even draw extra shapes or add on to these models too if necessary. So once you have all these models cleaned up, placed in the right location, and you're ready to go, you can even export them back to the file geodatabase and load it into your existing 3D city information model as 3D building shells. We allow for footprints and shells, 2D footprints and 3D representations to be called to. And then you can load them back into CityEngine. And what's great now about this is we can link to the building's usage data, attributes that the city may already have. Any kind of thematic information can be linked to and leveraged. And also we can then export these iconic models with the full scene that we created earlier directly onto ArcGIS online. So first of all, I showed you how to export that. Now we're going to show you how to load it onto ArcGIS Online. You can do it out of CityEngine, or some people like to just use the online interface, and they can choose and drag the file, select some metadata tags, figure out the name, and then it'll load this data directly onto ESRI's ArcGIS Online systems. So once you've got it loaded online, you can open it in the browser, you can add images, you can customize text, and it's going to load up this Webscene. And this is a static Webscene. It's zipped, compressed, and visualized in your computer's memory. Now, coming soon, we're going to have dynamic Webscenes and dynamic services that are going to be released with the release of ArcGIS 10.3 next year. So what we can also look at, as I mentioned earlier, thematics in 3D. So we already had some zoning data from the city, and I've simplified it to just residential and commercial usage, but you can actually visualize that with a swipe tool. So there's a lot of flexibility that you can have in this 3D interface and with web scenes. And you can link to anything. You could say crime data. You could have some kind of emergency analysis. You name it. It can all be visualized thematically. So again, these are the models generated in 3D FeatureXtract in CityEngine, mosaicked, we could say, together with our existing data or combined. And with that, allows us to get more accurate height study visualizations. You could also use the 3D Analyst tool to do similar analysis, but this allows for anyone to do 3D analysis on the web. You can use a comment tab here to make comments in 3D and some other capabilities, or even query your building information. So thanks for having me in this presentation, Kevin. I'd like to hand back to you guys to carry on. I guess I'll hand off to Jason.
Excellent. Thank you very much, Jeff. And I'm going to get back onto my screen here. While we're waiting for more questions to come in, we do have a number of questions that have come in already, but if you have one, now is the time to enter it. And I will launch our last poll. And essentially what we want to know now is, in essence, did you like what you saw today? Basically, what is the level of detail that you required or require and what you expect to be doing with 3D modeling compared to what we were able to show you today? And this poll you can answer any or all that apply on that there. So either the level of detail that we've shown you today is what you were expecting, what you were hoping to have, or perhaps you need something higher. And then secondary to that is, and I guess the answers do go hand in hand. Either you're more interested in aesthetics, your application, your output is more concerned with aesthetics, or perhaps photogrammetric accuracy is of key there. Excellent. Thank you all for taking part in our polls today. Quick share. I'm assuming it's probably the same people with the same answer. There was a number of people answered close to 40%. Were saying that the level of detail we were able to demonstrate today is excellent, and about the same number were interested much more in photogrammetric accuracy than they were aesthetics, which is great. Thank you all for taking part in the polls. And now I'm going to get to the question and answer portion of the session, and I'll try to direct these to the appropriate people. The first question, I suppose that it has to do for both 3D, FE, and CityEngine, but we have a question about the vertices on the wireframe. How do they pick up the actual Z values? And I guess I'll ask Kevin first. I'll open up both lines, but Kevin, I think you can start there, and we'll see if the answer is any different for CityEngine.
Yeah, I mean, absolutely. The Z values are definitely moved over and collected and stored in the database that is exported out. There's different formats that we showed: KMZ, shapefile, Collada, etc. All of those formats basically assume that you're going to be doing something with the data that is 3D. So definitely the attribute information is transferred along. Some things that I didn't show were, you can definitely drop points like street lights. You could draw points on trees, and you would be able to get like the base of the tree, the top of the tree. There's really, no limit in terms of what can be modeled in 3D. In 3D FeatureXtract. It's really depending on what you can see in the imagery itself. So the resolution of the imagery and the stereo quality, if you will, or the parallax that's available through the stereo pairs.
So on the CityEngine side, I'd say if you wanted to obtain the Z values, when you align those geometries to the terrain, it gives them an actual z-value that it leverages, and then you start your extrusions from there based on your GIS data attributes. But in the 3D CIM, or the 3D city data model that I mentioned earlier, there is a geoprocessing tool that will allow you to set your heights for all the building footprints, the base height, directly from your imagery as well. So there's a couple of approaches to making that happen.
Perfect. Thanks, both of you. I have another question coming in here. Is it a DSM that is required to be generating these building models, or is it possible for anyone to get the required accuracy through a DTM, a terrain model, if possible?
Yeah, so both are needed. Basically, we need the difference between the two, and that's essentially what Jeff was using. So he was using the DSM that we generated from Geomatica, and also the DTM, which is essentially just a filter to remove the surface features. And obviously, using those two layers, we can collect information on the buildings. There's a few more questions, Jason. I'm just going to keep talking here. So there's a question about whether there's an API that is available for handling input-driven building model generation. So I'll handle it from my side, and maybe Jeff can add to it. We definitely do have an API. Geomatica 2014 is powered, has the ability to use Python scripting, so you can automatically extract elevation models. We actually have a GitHub page as well. If you go to our GitHub page, you can download the source code and also link through to some data that we used for that to extract elevation models automatically through Python, basically driving Geomatica. Jeff, how about on your side in terms of API for input-driven building generation?
So we do have a CityEngine SDK, which will allow you to actually generate buildings and all sorts of other programs. You can write your custom scripts to go into SketchUp or other programs. We have the ability to go into Maya and the Unity game engines already. So it's just based on your needs. You can leverage the procedural capabilities of rules to then use your data attributes from the extracted imagery heights and go from there even.
Excellent. I have a couple of other questions that about specifically about the texturing on the side of the buildings. A two-part question. Are the textures that we see on the buildings, are they derived automatically from the aerial and/or satellite imagery? And if so, is it possible to take imagery taken not from that, like perhaps oblique imagery that wasn't used to generate the models, to in essence stick that on the side to generate your building textures that way in either product?
Yeah, so I'll let Jeff finish my sentence, but the wireframe that we export out can be just that, just wireframe. It can be brought into other software, which I'm not very familiar with, but I think Jeff is more familiar with. So we can texturize using the imagery as I described, or we can pass on just the wireframe information to be used somewhere else. Maybe Jeff, you can comment on that.
So on the CityEngine side, how it operates is we have folders of buckets. You can use a bucket of textures that you pre-create or ones that are existing in the data to texture the buildings based on a usage type, or generically texture them all with similar textures based on their variables. So you can customize and code this stuff with what we call CGA, or shape grammar, the programming language that CityEngine uses. And in doing that, it just basically says, okay, the building's this tall, the usage is this tall, or some other information. Let's give it this generic texture. But you can also, once you've made these models, you can update those textures yourself with ones that you have, or use imagery and crop them out that way, place them in buckets that way, like folders. Or you can actually collapse the buildings. You can edit the 3D FE buildings after the fact, take a picture and just place it on one face. There's all sorts of different editing capabilities that you can do inside of CityEngine too.
Excellent. And before I get to the next question, I do just want to call attention to people on the screen there. Both Kevin and Jeff discussed the free trials that are available for each of these pieces of software. You can look at the links on the screen there, and we will be sending out the slides and the recording afterwards, so you can get the links there also. Jeff, I believe you also said there is a trial of ArcGIS Desktop available that is not on this screen. but arcgis.com
yes,
is the way to get that?
Just go to arcgis.com and navigate to the trial page, and you can download a free trial there. And with that, you can test out all the tools, 3D Analyst, Spatial Analyst, and those tools are required to basically take those DSMs and DTMs and do the subtraction that's required, and then adding heights to your information.
Excellent. Yeah. So what's really great is we've put together a couple of demonstrations today, and all with free trials. People out there watching today can try it at home almost right away. I have a question for Kevin. I'm not sure if you want to take control of your screen for this one, Kevin, but not necessarily about the 3D modeling, but you're looking about can Geomatica specifically create a bare earth model removing the buildings before creating a DEM? Is that something you want to show right now, or just explain?
Yeah, sure. I can quickly grab control here and show the DEM editing tools that are available within Geomatica. Something new that we added with Geomatica 2014. So I'm just going to open up Focus. I'm going to open up again that DSM, which we generated using the overlapping imagery. So obviously what we have here is a digital surface model. What we can do is we can bring up our DEM editing panel, and if we want to get to a bare earth elevation model, here we can see that there's some natural terrain features, like this is a mound. You know, we don't want to remove this. This is not a man-made structure. This is not a building. It's a feature that we want to keep. So what we can do is we can very easily just create a polygon along this area. Now we can work on small or large areas. The tool is very flexible here. I'm just going to work on a smaller area and remove these buildings. There's a series of terrain filters that are available. The one that I'm pulling down is a flattening filter specifically made for terrains. I can change the size of the filter to remove, depending on the size of buildings that I'm trying to remove, and just simply click apply. And just like that, basically I've removed the buildings and I now have a digital terrain model. I could do some other filtering, like I can smooth out some of the bumps. I can run that a few times and maybe smooth out the pits, depressions in the DEM, or the DSM rather. So it's quite easy, as you can see, to edit the DEM and get to a bare earth DTM.
Excellent. Thanks, Kevin. And I have another one here. If you still have, do you still have 3DFE running there? I see a question about changing the image enhancement in that software. Is that possible now, or have you shut down the program?
Yeah, no, totally possible. Sorry, I just passed control.
Yeah, no problem. We'll pass that back to you.
Grab it again. All right, so I'll just select this building model which I created, and I'll turn it off. And you can see here on the home screen we have our brightness and contrast enhancements. So I can pull up the brightness or bring it down. I was having a little bit of trouble picking out that that octagonal feature along the dome, so definitely I can bring the brightness down, and there, now I can see it a lot better. So very easy to do that, and you can reset these to what they were quite easily and kind of move around like that. So very intuitive tool to use.
Excellent. Thanks, Kevin. And actually, a couple of questions I see here are sort of getting more in depth. I just sent out a message to everybody. We did get a number of great questions, and we will be answering them. But some of them require more in-depth answer than we can provide in this short time, and some of them we just didn't get a chance to get to. But like I mentioned, we did record this session, and we will be sending that recording out to each of you along with the slides in the next day or so. And along with that, we will have a transcript of the question and answer session, including questions that we did not get a chance to answer live today. So it is now the top of the hour. I want to thank everybody out there for joining us today. Thank you for the great questions. Thank you for participating. I want to thank Jeff Taylor from ESRI for putting together his portion of the demonstration, and thank Kevin for putting together his portion of the demonstration. And lastly, I would like to make sure everybody visits, in addition to the links that I showed you earlier, visit getgeomatica.com. That is where you can download the trial versions of software that we have available at PCI, and also we are promoting what we're calling a road show, where we are having a number of upcoming live in-person events and more webinars that are happening through to the end of October, where you can learn more about using imagery with GIS to produce interesting products. So thank you again very much for joining us, and we hope to talk to you again soon. Have a nice day, everyone.